introduce our first featured partner, SkyCiv Cloud Engineering Software. And our speaker will be Trevor Soleil. Trevor is a sales and onboarding engineer at SkyCiv, which provides engineers powerful and easy-to-use structural analysis and design software all in the cloud. He's responsible for leading SkyCiv's sales and onboarding effort in the United States, Canada, and United Kingdom, and is involved in product design and testing. Trevor has experience in both the construction and structural engineering industry, working as a project engineer for a large general contractor and a structural EIT for a full-service AE firm. And that's why we invited Trevor. I mean, he's got that experience as an engineer like you, and now he's being able to work on the SkyCiv software to kind of bring that experience full circle. So with that, I'm going to turn it over to Trevor.
All right. Thanks, Anthony, for the introduction. Thanks, everyone who decided to show up for the Innovation Showcase. I'm hoping this is really for you guys, and I just want to kind of showcase our platform, and we'll just get into it right away. So a little bit more about us. We started in 2015. That's our 1.0. As Anthony said, we're a cloud-based structural engineering software company. We service over 160 countries at the moment. And since 2015, we've had a range of over 200,000 users between students, professors, professionals, really any type of user you can think of. We've had that type of person with us. And the main thing that we try to distinguish ourselves as is an innovator in the industry. We kind of noticed that there were a lot of laggards in the software industry. It looked and felt like a lot of options out there weren't really up to date with the times. It looked like they were stuck in the 90s. And another goal that we have is trying to eliminate the black box effect. I speak with a lot of engineers that they have to trust the software that they see, and there's really no way for them to see what's happening in the back end or see what's happening behind the scenes. So we're trying to eliminate that, and we do both of these things because we're very feedback customer driven. We take our customer conversations very, very seriously. I talk with our users every single day to see what's working for them, what's not working for them, and we're always welcoming feedback. So Anthony basically summarized it pretty well. A little bit about me. I manage sales and onboarding here in the US and the UK and Canada. I've had experience with an AE firm and a general contractor. But mainly what I like to just mention is the reason I'm with SkyCiv now is I really like to help other engineers discover new ways to do things and discover better ways to do things. And subsequent to that, I like to kind of be the mediator between our development and engineering team and the actual practicing engineers to try and make the best possible product for you guys. So just go over our agenda a little bit, but before that, I'll say that we definitely could take hours and hours to go through our platform. Just like any other alternative, there's a lot of content there, but obviously you guys at the end of the day are going to be the ones that want to use it. So that's why we offer free trials. That's why we want you to get in there, try to break it, do as many things as you can, just see if it's a good fit for you guys and your team. But we'll kind of go over the dashboard. We'll kind of do a quick overview of some tools, but the majority of our showcase will be spent on the 3D modeling analysis and design phase and just kind of highlighting some differences there. And then we'll wrap up, and then hopefully we'll have time for a couple questions. If not, I'll put my email in the end, and I'm happy to help and talk with anybody that wants to speak after this. So we're going to back out of here. And here's our dashboard. So when you sign up with us, whether you're any type of user, this is kind of the hub that you're operating from. You can see that we're in an actual browser here. We're not in a separate program. We didn't have to download anything. We just signed up basically in 2 minutes, and this is what we're getting. Everything that you see here is part of the professional account. So you're not paying extra for other modules. You're not paying, for things that you don't really see. Everything you see is a part of that. But what I'll do is I'll touch on the file manager here. Again, being part of the cloud means that we have unlimited cloud storage for all of our users. All of our cloud storage is backed up every single day. And it's SOC1 and SOC2 security compliant. So, you don't have to worry about backing up your files on your own local drive. We've never really had any issues with people losing their files or people, having to, or their files being corrupted or anything like that. But what's nice, in addition to having that security, is being able to share and have a single file. So for example, I'm just looking at a beam analysis file here. What's nice about our platform in being in the cloud is that there's one file that you can share between all of your team members. You can share between the support team. It's one file that's one source of truth, and there's no need to have multiple different versions of the same file in different folders and with different appended dates on them and stuff like that. There's one file that's tracked for every single project. So we'll go back to the dashboard here. And so the main, like I said before, the main thing we're going to touch on is the 3D module. But some of the things I wanted to just breeze over quickly and just show the UI would be the beam module, the section builder, and the load generator. So when you go into the load generator, I already have a calculation set up, but generating design criteria is something that most engineers have to do. So this is where you'd be able to do that. You can put any location that you want, and it's going to generate all of that information for you. Just like you'd have to go through the ASE 7 checks, this can do all that for you. So you're getting the wind loads, the snow loads, the unbalanced snow loads. There's main wind force resisting system components and cladding. All that stuff is automatically generated. And along the same lines of the black box thing that I mentioned earlier about trying to eliminate that, a lot of these things we tried to incorporate as a deliverable as much as possible. So this whole screen with all of your pressures and stuff can be exported as a PDF. But even more so, we want to show you what's happening in the back end of it. So there's the deliverable that shows just the pressures and stuff kind of for your own sake. But we also have a hand calculation here that shows, okay, are they getting the effects correctly? Are they calculating are they pulling the right values? Are they calculating the velocity pressure correctly? And this can be exported as a PDF as well. So you'll see that as a theme as we go through. We try to deliver on as many deliverables as possible, but also give as many hand calculations where applicable. So that's the load generator. The second thing would be the section builder. So this is our version of a custom section analyzer that's also fully integrated with the rest of our modules. So in this module, you can import DXFs of custom files or custom sections. You can analyze database sections. You can append things together, kind of play around with really whatever shape you want, with whatever materials you want. For example, this is just a user file that we had where somebody gave us this pretty crazy looking file that we were able to calculate all of these properties for. And it's actually using an FEA analysis to generate these properties. So they're very, very, very accurate. And like I said, the properties range from simple geometric properties all the way down to torsional. And this, again, is integrated directly with all of the modules so you can use in 3D analysis and design and stuff like that. So really quick 100-mile-an-hour look through that. The last one I wanted to brush over before we get into the main bulk of it would be the complicated, or the beam module. So I have my complicated beam file here. Basically, this is probably our most popular module because of how quickly you can get a result. It's our most popular module because it's the easiest to use. The reporting is really simple. So we can see we have this very complicated beam here with a variety of different support situations, a variety of different loads. Not only are we getting the shear force diagrams and the moment force diagrams, we're getting the equations for those diagrams, and we can get the hand calculations for those diagrams if we choose to. So there's really a full, you can get as deep in the woods on this as you really want to. And that's what our goal is give you the choice to be able to kind of look at that stuff yourself. And if you see here, we do have the custom section that I just showed you guys as our applicable section. So other things that you can achieve with a really quick beam calculation would be, deflection. Hand calculations for the deflection are coming soon. Displacement. If you're more of a rendering and color contour person, all of the results you see can be rendered in this space. And then just some good old-fashioned stress results. And just like before in the other modules, this can be output basically as a printable PDF. So like I said, there's a theme there on trying to give you as many deliverables as possible so that you can have something of value to give to your clients, something of value to give to your architects. So the main thing we want to look on is the Structural 3D module. So this is an example project that I have set up for us. There's a variety of different members here. There's a variety of different things going on. There's some bracing. There's some floors being framed. There's some truss elements. It just has a bunch of different things. And this is an actual user project that we have. So the first thing I wanted to mention is the import functionality. So, if you're, whether that's starting from scratch or starting from another file, there's a lot of things you can start with. So if you have a Revit model or a DXF or a drawing, or maybe you're starting from a STAAD Pro model or any one of these other options, you can start with that as an import, and then similarly with the export as well. So there's a lot of import export to kind of give you a head start on your model. If you're the guy or the girl who is used to modeling using just a spreadsheet, if you model all your stuff in Excel and you copy and paste that into something like this, that's also supported here. So we try to make our inputs as graphical as possible, but if that's something that you want, we want to give you the choice or the ability to copy and paste from any other spreadsheet. And you can also do all that same stuff in here. So not only just the nodes, but the members and stuff like that. But the main thing I wanted to go over was some of the graphical tools, graphical input tools. So, there's the data sheets that you can manipulate, but something that I like to use in my projects when I'm working on things with users is the pen tool. So in other cases, the pen tool for other alternatives, usually you have to generate all the node data, all the coordinates, then you have to draw the members in between them. Whereas with our pen tool here, all it takes is a single node to start from, and you can generate any type of appended structure or really anything. So I use it a lot to draw frames. I use it a lot to draw 3D platforms and just really anything that you can think of. So just an example here, we have our structure here. And let's say we wanted to create like an overhang that comes off the side here. Instead of having to create all of the 3 or 2 nodes that we want to generate, we can just start with a node here. We click on it, and we can see that not only is it telling us the projected distance that we're traveling as we move our mouse, it's also snapping to the XYZ global axis. So it's giving us a blue dotted line telling us, hey, we're on the global Z, and we're 5, 10, 10.3 feet away. So for example, if I wanted to create a 6.1 foot overhang, I can go 6.1 feet out, click it, and then I can continue chaining these. So now I'm going in the in and out direction. So it's not just 2D, it's 3D modeling. And then what'll happen is once it gets to the end here, it's going to kind of recognize points that it's lining up with. So we can see that it's found the other side of our structure, and I'm going to click on that. And now I can just kind of jog this back in. And now we have our overhang there. And obviously when you have a type of model or a type of structure where you can't just pen tool everything, you can't just draw everything, that's where operations come into play. So things that you're probably used to seeing are repeat, mirroring, this is rotate copying, curve and spiral members, shifting, scaling nodes together or apart, and then switching your vertical axis. These are some of the basic ones that mostly everybody knows how to use. But what I use a lot of the time, and I think is a pretty big value add or time saver for our users, is the ability to have a lot of the functionality within just a right click. I always like to say right click is your best friend. So for example, if I click on any member here, I can always right click and see what are the options I have to adjust that. I don't have to worry about clicking on a drop down or going somewhere else. I'm just clicking on a member, I'm right clicking, and I can add a bunch of different loads. It's that way for nodes. It's that right click functionality is there. So what I can do, for example, here is click on a member, and this is just one of many operations that are kind of within the right click, is I can grab these 2 parallel members and I can span between them, simply identify a spacing, and now I have a fully framed roof there. And now I can continue modeling either the appended structure to this or loading it up or whatever that may be. So that's the pen tool. I'm going to back out of this. I'll undo a little bit. So that's, again, 100 miles an hour of the actual inputs. There's a lot of things that I didn't really mention, but what I'll do now is I'm going to look at the grouping functionality. So this is something that you can use from the modeling stage all the way through the design stage. So what this is allowing you to do is you can manually create groups of members, or you can have the software automatically group for you. So if I choose to auto group, I can group a lot of my members by material, length, direction, or section. but I'll just do material and section to show you what this is doing. If we group these together, it's going to try and tell us here's the groups that we found. So it's basically just going to group them based on what the section applied is. We'll add these to our groups, and if you want, we can manually adjust these. So for this one, it's like the exterior columns plus a couple of the roof ridge items here. But this group, let's say, let's just call this like the central columns or something like that. That way, you have a better idea of what it is. But what's nice with groups in this case is the fact that if you select a group, you can basically edit it all at one time. So it's easier for the actual selection process. And now from here, all I had to do is select that group, and now I can change all these members at one time. I can change their section, I can rotate them more, I can change their member type, adjust their member infixity, stuff like that. So that's where that grouping comes into play. And we'll see that come into play in a little bit as well. So one thing I wanted to mention too before was the template assemblies. So this is kind of the last thing that you would be able to add with. So if you're starting from scratch, or you're starting from a member, or really from anything, and you have a structure or a type of structure that is pretty basic, or even we've had some pretty wonky looking things in here that we've created templates for, like a crane system or a shipping container, solar panel, Science Olympiad even had one in here, stuff like that. You can start from a template here. So that's going to wrap up the majority of the modeling stuff. We'll get into loading a little bit here. So what I have shown is a variety of different loads, point loads, distributed loads. Won't really go over those. Those are pretty self-explanatory and are going to be, pretty obvious when you guys are using other softwares. But some of the different area loads that are available are shown here. And what's nice about our visibility and making it more graphic for you guys is if you turn on the equivalent load factor or load option, you can see, okay, here's the pressure that you're applying, or the area load that you're applying, but what's actually being distributed to the members and how that's being calculated in the back end. What's the solver actually using to run the analysis? And that's where this would be. So examples like a simple one-way distribution for this whole floor here, we can see that. This load that I have applied is pretty nice. It's the ability to basically have an entire area that you apply to, but you can vary the pressure or step the pressure as you either go in like one direction, whatever this distribution is on. So for this example, this would be good for lateral wind or like roof loads where you're trying to have to step the loads and pressure, and it's going to basically do that in a one-way distribution. And then lastly would be open structure type loads. So you guys are obviously probably pretty familiar with that. You apply a pressure to an area, and then based on what the tributary width is being exposed to that load, that's what the load would be. And that's why we're seeing a higher load on this middle column, because obviously it has a bigger flange width that's being exposed in this small tube here. So those are the loads. We're going to go through a quick example here, or a quick analysis. So just that was a couple quick things, in terms of the actual generation. Obviously can't go through everything, but we'll do a quick solve here. Just did a linear static solve. There's a bunch of other things you can solve it with: P delta, buckling, a couple of like response spectrum analysis, dynamic frequency. But when you're in here, we're trying to be as visual as possible. So viewing any different load combinations, load cases, envelope cases, load groups, things like that. It's going to actually display the results on the structure itself. So for this example, we display the moment results. Here, you're not going to get a bunch of value because there's just so much stuff to look at here. So where the groups come into play here is you can basically filter the results. So we'll do axial, say, and we can filter through the results and say, okay, now it's easier for me to tell, here are the middle columns that I have, here are the axial results I have for this individual load combination. And that can be done for any number of these results, for any number of these groups. When you're ready to kind of get to a deliverable stage, you can print an analytical report, and If you really wanted to, I get a lot of comments about, the reporting is kind of messed up in stuff I use today, because all it does is give me, rows and rows of useless data, which obviously we want to be able to give you a reporting tool that adds value for you. So it's basically from our perspective, giving you the choice to whether to have that or not. So you can select as many load combinations as you want. If you really wanted to get in the weeds on it and look at the individual member forces along the different checkpoints and the different nodal results and all that type of stuff, you can do that. But you can also keep it as simple as you want. You can just do a couple of different things. So what I like to show here is just maybe for a single member here, we can do kind of a detailed member report. And I think this, in my opinion, adds a lot more value than just tables and tables and tables of information that might not ever be looked at or investigated. So if I create this report, it's going to generate that, and in the background, we can still look at some of the results if we want. But the report is going to generate, it's going to pop up for us, and then just like in the other cases, you can generate a PDF or an HTML of that. So if we view it, if you have a custom logo, that goes here, or I should say a company logo. And then here would be your example analysis report. So this is about as simple as you can get. So you're getting, the data that you really want. You're getting just for the problem member that you have. You're getting the member summary tables. You're getting the results for that load combination. You're getting all the properties for that member, and then you're getting the graphs for that in these two cases. And this is another deliverable that you can have for your own sake. And it can be, like I said, downloaded as a PDF or as an HTML. Okay, so that goes through the majority of what I wanted to touch on with the modeling and with the analysis. We're going to go through a little bit of design now. So if we go to design and start new code, this is the design phase of it. So we have our project details, our design factors that can be adjusted, our member data that can be adjusted. So, if you're wanting to adjust anything like the unbraced length, KY, KZ factors, this can all be adjusted here. So if I wanted to change this value, I could do that. And then I can, drag this down here, and I can adjust or manipulate as many members as I really want to. So we'll run a check here quickly. And actually, I'm just realizing that I have it in ASD. Silly. We'll do it in LRFD because that's what I had the load combinations in. We'll run a check. We can see that the majority of our members are passing here. It's giving us a really good look of our module, or our model. So we can see there's a couple of red members here that need some addressing. There's a couple of bracing members here that need addressing. But what's nice about the groups in this stage is that it's telling you, okay, for all of the groups that are all the members that are part of this group, you can filter those in the results. You can filter the column results. You can filter, okay, we have a couple issues here. But that's nice to be able to give you a better visual aspect of what you're trying to find. In this case, we have a couple of members here. If you wanted to actually optimize your structure and optimize the members of your structure, that's available in the designer up here. So if we look at the settings, when you're optimizing the members in your structure, some of the variables that you can adjust are excluding certain sections. So, we do have the full library all the way down to W4s. So if you wanted to exclude anything that's W4, W5, W6, or whatever it is, you can exclude them. You can restrict the section height, restrict the section width. You can manipulate the utility ratio to be as aggressive or as conservative as you want. And you can use you can optimize as few or as many sections as you want as well. What I wanted to show though is, let's say for this case, we have a couple warning members, and we can run the optimization. But what I want to show is the black box effect when you're going through a design, or you get a design from a software and you click design, and it just gives you basically what you see here, where it's just giving you the single values of, okay, here's your unity ratio for this and this, and you have to kind of go on your own judgment to say, I believe this is right. I want to, I think I put everything in correctly. There's really no way for you to 100% know what's happening. Whereas what we try to do with the majority of our designs, whether that's for steel, whether that's for concrete, whether that's for wood, whether that's for cold form, which we try to integrate these hand calculation level design reports that you can use as deliverables, either for yourselves, for mentorship with your younger engineers, or to deliver to your clients. And what the hand calculation level reports are going to give you is they're going to give you all the information about the member, and they're going to give you all the checks with all of the code requirements, or all the code references, that they use to get there. So for this HSS member we have, it's giving us all the dimensions, properties. It's giving us the forces that it's being designed for. And it's going through and saying, okay, for AIS section E2, here's the slenderness check. Here is the flexural check. Here's the section. Again, here's the sections. So very, very detailed ways to show, here's how we got to that 0.004 value. Here's how we got to that factor of 0. That doesn't really give a lot of value, but here's how we got to 0.990. That's why this is a member that's in warning, is because we have the combined strength check here. So this is something that we get a lot of positive reinforcement on from our other current users, because they don't really see this in any other option that's out there, is this level of verification, this level of hand calculations that you're able to then use. So again, sorry, go ahead.
Oh, Trevor, it's Anthony. I was just going to let everyone know if they had a question for you. If you had a question for Trevor,
yeah,
we have a minute or two to go here. If you could put it in now. But also, Trevor, while we're doing that, I know you wanted to give out your email in case somebody also thought of a question that they could send to you.
Yes, I kind of I've been trying to keep this short, but I ended up going pretty long sometimes because there's just so much stuff that I want to give. So basically that was kind of it on that. And then here's a couple feature snapshots and some of the things that we have upcoming. And all of this stuff is available on our platform for $109 a month. So any update that we send through to you is automatically added to the account. There's no update fees, there's no upgrades, there's no maintenance fees, there's nothing like that. And what we want to show to you guys is to say, hey, go check it out yourself. We offer 14-day trials, but if you attended this seminar or this webinar, head to skyciv.com/EMI and get an extended 30-day trial. And like I said, I'm very open. I love to hear feedback from you guys, questions. My email is right here. It's just first last name at skyciv.com. And like I said, I'll answer any questions that you guys have. But definitely head to this website or this URL, get that extended trial, and I'd love to hear from you guys, in the future, hopefully very, very soon.